Hey everybody, this is Larry. This is day 23 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's forum. I have some allergy stuff, so if I'm talking really, well, it's just allergies. I apologize. I am recording these live, so if it's a little bit slow, fast forward or watch on 2x or whatever you need to do. And today's problem is find the shortest super. Hey, yeah, so I cut in here to kind of go over the solution because this video was very long. You could still watch me solve this live afterwards, but I just wanted to put the explanation in the beginning because this is a long video. Let me know what you think about this pattern. Yeah. So first of all, what I first did was I filtered the list. There's a lot of greedy things that I'm doing here, some of which I actually talk about if you watch me sub it live, but I remove words that are quote unquote dominated by other words. And what I mean by that is that if a word fits totally in another word, then it's going to be inside that word for the entire time, so it doesn't need to go in anywhere. So I just have this and I filter those out, right? Because if it's inside another word, that means that the bigger word's answer is going to use it anyway. And then here I calculate the overlap, the maximum overlap. Yeah, I just calculate the overlap and the longest overlap that after appending words J after words I. I spent a lot of time here actually, but hopefully this makes sense. You just calculate the overlap in the number of characters. And then here is the tough part. This is the Bitmask part. This is dynamic programming. I also go over the Bitmask part a little bit in the video, so you can go skip ahead a little bit. But basically, we use Bitmask like a Boolean vector of 12 elements because n is 12. So this is the Boolean element because you can think about mask as a binary number that has ones and zeros, where 1 means index, this index is usable, and 0 means that we already used it. In this case, it means that the 0th item we already use, we can use it, and this first item, the first item we already used it, so you cannot use it. And the rest kind of follows. I'm not gonna go over it that deeply because that's not the point of this video. Sometimes I go over it, but today I'm really tired. If you really like a Bitmask video, let me know. I think I've done it before, but I don't know. Let me know anyway. So yeah, and basically this function asks to get the best word where the previous word is word sub I, or good word sub I, and mask is the items that the Boolean table that we talked about, and then we kind of check if we use all the words, then the last word then the last word we use all of the last word because there's no more words to overlap. Otherwise we see if it's in the cache. If it's in the cache, we return the cache. We also kind of store the word here, and then here we just kind of keep going. We have send no values, but we basically go, okay, if I add the word J to the current I, what would be what word would we get? So we basically do that. We look at the overlap, we get the subset, and this is recursive. We get the current word, which is the current word plus the stuff that is added on, which is this part. And then if it is the shortest length, we update our shortest answer, and that's pretty much it. I also do a trick where I append an empty string to word, so then it saves me writing something outside the loop, because now we just start from that empty string and then go all the way in. Doesn't change the complexity. But yeah, so what is the complexity? Well, I is just an index, so it goes from 0 to n, so this is O of n. mask goes from 0 to 2 to the n, so this is O of 2 to the n, technically 2 to the n minus 1. So then the total time is equal to, or total number of inputs is equal to O of n times 2 to the n. And of course, for each core, this does, for each input, this does O of n work, because note the for loop here. So the total time, total time is O of n squared 2 to the n. Roughly speaking, yeah. And that's pretty much it. So the space is O of, you could say, is the number of inputs times the number of bytes that each input. So that's going to be, for each word there's 20. So we're going to is this times m, where m is 20 in this case. We technically do a little bit more random space things by allocating stuff, but for the purpose of hand wavy, that's roughly it. That's all I have for this problem. Yeah, you could watch me struggle on this problem next. I actually, for the most part, got it quickly. I just kind of have a lot of issues with off by ones and indexes and stuff like that, and you could watch me struggle. I'm really tired, so I'm going to pass out right now. So yeah, let me know what you think and watch me solve it live next. And today's problem is find the shortest superstring. What is so super about it? Okay, smallest string that contains each string words and substring returns any of them. Return the smallest string that contains each string and substring. Is it in order, or no? It doesn't have to be in order. That is this is an annoying problem. The short answer is that it's going to be some I mean, 12 factorial is a little big, but you can actually do it in can you do in Bitmask? I don't know. Let me think about this. It is a little bit slow, sorry. I really don't have great ideas that on brute force and I'm trying to think about, what I'm thinking right now is just trying to think about the clever ways to do it in brute force. I mean, definitely you can pre-calculate some of these, but yeah, but it is still going to be kind of annoying. And I don't know if this is one of those silly Leetcode problems where the inputs are just not that interesting, so that it allows you to do it that way. So I think one thing to note is that the ordering. Okay, I think I have some ideas about how to make this a little bit smarter. The key thing to note, I think, for this problem is that if these two words don't intersect, then the order doesn't matter, right? So you only care about stuff that intersects, and for stuff that intersects, trying to think whether, yeah, I think you could just brute force try all of them. We have some weird, like a lot of A's. All the strings and the words are unique. That makes it a little bit easier, but yeah. I don't know. I think there's a lot of some in my head. I'm just going through a lot of cases, and a lot of them are kind of greedy things that I'm just trying in my head. Where I'm like, okay, is it okay to just always extend only extend? I guess so. Because then we can do some subset bitmask thing, which is 3 to the 12 in theory. And then, 3 to the 12 is fast enough probably. Especially if you do some pre-processing, that's 500,000, 531,000. But that's really high powered. That's why I don't want to do it. Or like, that's a lot of explanation for that one. Especially with pre-processing, 20 length, 20 square. Maybe it's fine. So there's that case, and then there's that case. Okay. Okay. All right, let's go through a few cases. I don't even know if this is right, but it is still going to be some sort of brute force, but with a lot of filtering. And the thing that I noticed is that you can have disjoint sets, and if you have disjoint sets, then you just kind of handle them outside. But then now, remember that you not only return the length, you return the string as well. So it's a little bit more annoying as well. But yeah, okay. I mean, it is what it is. Let's try to play around with a few things. And now, first thing I want to do is just get rid of strings that are inside other strings, so that we don't have to consider it, because you always just it gets dominated, so you just use the bit longer string, right? So yeah, yeah, good. Maybe good words is equal to this. For word in words. Let's see. For word 2 in words, dominated is equal to false. If word is in word 2 and word is not equal to word 2, then dominated is equal to true. If not dominated, then good words append word. Okay, so now we have all the words that are not dominated, and then now we can this is so annoying to code. Basically what we want to do now is we want to yeah, okay, let's just do a recursive function. Let's just do get subset, maybe something like that. I'm going to use the bitmask here to keep things a little bit easier to write. And I'm going to do a 2-minute thing on bitmask, which is that bitmask is it's going to be it maps to basically for each of the n words. Let's say n is equal to length of good words. Oh, let's actually set up the how do you do starts with there's just so much pre-processing, and I'm a little bit lazy today. I thought I was going to go to sleep early today, but okay. But yeah, basically bitmask, what a bitmask is that it has a binary representation of a number represent a binary number, and for each of those bits you have either ones or zero. And a 1 means that the index I is used, 0 means it's not used, or the other way around, depending on how we want to do it, or can be used. So that's basically the idea, is just mapping like a vector of booleans, basically, is what it's doing. And then so that we can do something like cache data. We're going to put it in a dictionary. So if mask in cache, return cache mask, something like that. And of course, if mask is equal to 0, then we return empty string. Right? Do I want to do it this way? I don't even know. And then after that, it just becomes a graph problem. Of like a Helm cycle. So you have like, you take each component and then you get the Helm cycle answer of it, which is really yucky. Yeah, I mean, it is what it is. And then I think we also just do it more proof, more whatchamacallit, just more pre-processing. Like I said, there's a lot of pre-processing in this one. I don't even know if this is fast enough, but we will see. And then now we can get, basically for each subcomponent, it is maybe it's fine actually. Maybe I could do it this another way. Yeah. Okay. So then now we calculate the cost. Yeah, I guess this is the length of each word is only up to 20. So let's just do cost is equal to -1 times n for the n, and then now you have, let's just do for k in range of from 1 to length of length of word sub I. So basically what we want is the cost of appending word sub j after word sub I, right? So then now we do a thing where, okay, if word sub j starts with the end of it, which is word sub I of the last I guess just k, something like that. Then cost of I to j is equal to k, and then we break. Okay, I think that's good. Oh no, this has to be good words. Whoops. Okay, I think now we're good. And then now we can just, I was going to do them in 3 to the n one, but I think we can actually do it from 2 to the n. So yeah, something like this. If index is equal to n, we return empty string. No, it's fine. No. If mask is equal to 0, then we return empty string. Doesn't matter. The index doesn't have to be in order. That's, yeah. And then now we try, okay, I think I got it. So basically now we try, okay, this gets the best word that starts where the last word is indexed, and mask, it's still able to be used. Contains the items still able to able to be used. Okay, and then now okay, so now we do for j in range of n, we go from index to j. I guess maybe I could just do I in the same thing, keep it consistent, going back and forth between index 2 and j, but maybe I and j is more CSC. But yeah, if mask 1 to j is equal to if this is greater than 0, meaning that this is a relatively used, then we get yeah, I was gonna say, so the cost is equal to, oops, okay, the C is equal to cost up from I to j. So that means that we extend this word by this character by this much. So let's say answer is equal to some empty character. Oops. And then now so then the suffix is going to be get submask of j, and then mask, we flip this. So this is what we get. So we get the word, but then now, since this is the cost, how do I do the cost? So the cost is going to be the length that we extend by. So that means that the suffix is going to be something like length of good words sub j minus c. So that's the thing that we're pending on, I think. Let's do best length is equal to I don't know, 1 billion. No, just keep it small, something big. I know that it's not 1 billion, but okay. If length of current is smaller than best length, then best length is equal to length of current, and answer is equal to current. And then at the very end, we just return the answer. Yeah, and actually we probably want a big number. I just say 300 and then whatever, something like that. And in the beginning, we want to try starting from every word. So it's gonna be for I in range sub n, get subset of I to 1 to the j, 1 to minus 1, and I think that's good. Something like that. Again, we do this best length of 0 to 300, answer is 0 to 100. So then now we get the subset starting from here. We can also just cheat a little bit and add an extra empty word in the beginning and then start from that one. Maybe that's a little bit easier. Okay, let's do that because I'm a little bit lazy today. And then this is going to be just n minus 1. So let's do n minus 1, do this, and then Maybe? I don't know. I don't know if this is quite right, but hopefully. Let's see. Okay. Get submask is not. What did I call it? Get subset? What did I call it? Get some. Oops. That's not good. If mask is equal to 0, that means that we used all the words. Oh, I have to. I don't use the words anywhere, so I have to figure out how do I incorporate that back in. So this is 0. This is this. How is this? Let's see. If the cost is whatever, then is that right? That seems a little bit awkward though. Well, it's slightly closer than the last answer, but so we extended by that length. So we extended by that length, and then now I could also use path reconstruction, I guess, instead of doing it this really funky way. Yeah, I guess usually, not usually, but in the past I would have done it that way. Oh yeah, and also this is, should be because maybe it's caching the wrong thing actually. Also, we don't cache, so maybe it wasn't caching the wrong thing. I mean, I think this is going to be roughly the right idea, but I'm getting the indexes really wrong. It's really late at night. I am really sleepy. But, Let me empty string. Okay. Oh, I see. No, I know what I was doing. Because basically, if these are all used, then this is actually just good word sub j. I mean. Yeah, okay, that didn't do anything. Why not? Oh. Wow. Let's see what we're hitting up. Maybe we're just being silly. Does seem to hit a lot of things. Do we ever get to the base case? We do, so well, this seems to be working for some definition of working. Yes. J, C, current. Just more debugging stuff. This is a hard one. Just annoying one. Decode, okay. What is that number? -1. Oh, this could be whatever. Whoops. So actually, otherwise, J is equal to the length of J. Okay, still the wrong answer, but maybe hopefully a slightly less wrong answer. Where's the Alex loves Leetcode thing? Why is it not printing at all? C is 0. No, that doesn't make sense. It seems like it is doing stuff. But not quite enough to stuff. I mask. This is tiring. Okay, let's get rid of this one for now. Debugging is tough. That's why I don't do it. Just write it correctly the first time. You'll enjoy it much better. Okay, so we go start from 3. So 1, 2 goes to 3 is the empty string. 15, and then that goes to oh, this is wrong because I want because it was adding to, itself, which is really awkward. Okay. So now 3 goes to 2, which is that right? 4, yeah, I guess that's right. J and C is this is 8 going to 2, which is true. So then why is that not giving me the right answer? Let's see. So this is returning this. And then we tick. Did I mess this up? What do I want from this again? So if the cost is that much, then we want to keep the last C. Okay. Maybe. Because that's the part that extends. I think they're the same, but at least this is slightly more easy to read. But that's odd, because for this, the cost is 8. But so we want the entire string starting from okay. Yeah, I just messed up the indexes again. Well, this is so silly. I mean, like for me, I am very silly. Oh, I still don't add in the current word. So this should be Okay, oh man, what a brain fart. Let's try that. That is way too short. I think my C math is still wrong. So if it extends by, say, 3 or 5, then that means that we just want the last. We want to skip the first. Okay. So actually, just this maybe? If the cost is 0, then no, because if the cost is 1, then you actually, that means that the overlap is all except for the last one string, right? Yeah, I don't know why this is wrong then. Wow. So this is the C is the last 8 characters. What am I doing here? Is that off by 1? Yeah, why is the last 8 characters not right? Like if this is R and this is -8, is that not right? Or am I just off by 1? Yeah, I just have off by 1. Nope. Or at least not only that. Now it's still not printing it. Because current is now this. What am I trying to do here? What are my indexes? Why am I so bad at string indexes? It's always really bad for me, to be honest. Because R is Leetcode in this case. So we want the last 8 characters. Why is this not right? Do I not know how to do it? No, it goes to all the characters until. Did I mess it up again? Sorry friends, I'm really bad at this clearly. Okay, that's what I meant, the last 8 characters, because mixing indexes and everything, I think I keep on mixing them. Okay, but it's still wrong. And that's fine. Or at least slightly more fine. But why? And why am I only returning 5? If the cost is now, because if the cost is 4, then we just want to skip the first length of good words. It should be sub J, not sub R, that's why. And then so we want to skip the first C characters. And this is why it's important to get enough sleep. So okay, so at least this one's good. Let's see why this is not good. This clearly does not contain all the strings, but So this is the end state. Five. 3 is this length, or which pretty bad. So that's probably right. So this is first. Okay, so it goes from 5 to 2. Did I do it backwards? Maybe I recurse backwards by accident. Is that true? No, it should be okay. Okay. So it thinks that this is the answer because it goes to 2. And 2 is 4, so it's this one. So it should save this as the answer, but somehow we're only getting this. Is that right? I messed up the best length thing. Oh my, I am so tired. All these are really short, and I don't know why. You have to cause is it? That means that the first. Did I mess this up? So if this starts with the first k characters, then the cause is not k. This is actually the overlap, not the cause. That's why I got it confused. Okay, that's. Then in this case, if this is the overlap, then we can ignore the first C on this character. Okay. Still wrong, but let's add some debugging. I hope this doesn't just print list. Okay. These are the choices that we're given. How did that happen? Didn't it work for a second? Or like at some sort of answer, even if not the correct one. So the overlap is C. Because if this is this overlap correct? If it starts with the last one character, then the overlap is 1, okay, that's fine. But it's not the maximum overlap. This is really weird though. What? Why? Overlap is going to be 0. Oh, yeah, then in this case, the default overlap is 0. Oh, okay. Still wrong, but at least we kind of have an idea. So these are our choices. That's fine. We chose this one. Let's trace it to here. We have these choices. Let's even print out, add a little bit more debugging. I'm passing out. Okay, so it goes to 0, so it's using this one. Is this one because it goes to 2? But why? Okay, maybe that's fine. No, what is... oops. 0 is cat G. And 2. Cat G 2 is GCTA. That's fine. Let's see. Let's see if I cut it off anything by accident. Wait. If it is 0, that means that it flips off the 1 bit, so it should be 0, 30. So actually, it should be this one. This returns this stuff, so why is this so weird? This is what it returns. Why does this look like that? Huh? This is also, the sad thing is that this is not really that interesting of a problem. I'm just really struggling with it. So this is the suffix, because this is the because we think that GCT is the overlap, but this doesn't, GCT doesn't even appear here at all. So because the current 0 is cat G. Cat G, we think has 3 overlap with GCT. That doesn't make sense. If this word starts with did I mix up the J's and the I's? Why is this so weird? Why is my overlap so weird? Because there's a lot of zeros. Well, I mean, that's expected, but from 0 to 2 has 3 overlap, which we know is not true because from 0 to 2 there is 1 overlap. Why? Did I have a typo somewhere? I mean, this is clearly not right. Word sub J. So if it starts with this, no, that's right. No, that should be 1, right? Why does it return 3? Why are you 3? Am I just thick? Why is this 3? So what am I saying? So if it starts with where's K? K is 3. K is 3 means that okay, so the overlap isn't K. Is it? No, because if K is 1, then the overlap is from, yeah, okay. I think I mixed that up again. So this is actually length of good words, I minus K. Silly mistakes. Okay. Oh, why am I so really bad right now? My excuse is that it is 4 a.m. in the morning and I need to pass out, but okay, this looks good. Actually, exact same answer, which is actually surprising because there could be multiple answers. Where are my other print statements? Okay. I'm gonna give it a submit. Well, as soon as my thing works. Is my internet down? My internet was down earlier. Okay, internet seems okay by me. But this prompt kind of disappeared. Oh no, there it is. Okay. Yeah, let's give it a submit. I think I clicked on it, but okay, there we go. I actually clicked on it. Oh, was really hoping because I don't want to spend more time debugging. But let's see. Why do I have this long thing? Let me put these test cases somewhere before I lose them. I guess that's just the input. Is this frustrating? 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 Okay, so the extra letter is, yeah, so that's the extra letter between okay. Why do I only get to choose between these things and not this one? Do I have this as an answer anywhere? Oops. Nope. Why not? So we want to go to 2 first. But the thing is that this is the shortest word. Why? What's the word? Sorry gang, this is really long and I need sleep. Maybe that's why. That's my excuse, I'm sticking to it. But okay. So things 2 should be first. And 2 has these things. Right? So it's this word plus this word, which the overlap or the extra part is this part, which is not true. I think it seems like I'm off by at least 1. Let's see. Now this part is the part that we want to add. This is the whole word. Okay. So should have been better about debugging. Should have done it in the morning. Maybe that would have been better. Okay, so now we want to look at the first. So this is the first one. This is the current word. We somehow think that this is the part to add on to it. So that's why we have this, but why? What is, oh, let's see. So the overlap is 1 between here, between word 2 and 0. Is that true? Word 2 and 0 should have 2 overlap, but I only wrote 1 overlap. Am I off by 1? I have to. Okay. Because I want the maximum of this, but before I had it flipped around, so okay. Oh jeez, this is so annoying. I had the right idea actually the entire time, but didn't really help. Okay, so let me paste back the stuff. Okay. Actually, I guess we might be using the same algorithm, but anyway, let's click on submit. Okay. Yeah, I mean, I'm not going to explain it again because this video has gone on for long enough that I probably, or I explained it in the beginning and we recorded it. So yeah, I'm tired right now. If you're still watching, you could see the tiredness in my eyes, and I'm going to go right to sleep. Hit the like button, hit the subscribe button, join me on Discord. Thanks for watching this late if you're still here. Yeah, hopefully next week will be better, and I'll see you tomorrow. Bye bye.